Venus's atmosphere. If you were somehow standing on the surface of Venus right now, the sound hitting your ears would be the last thing you'd worry about. And what's wild is that we actually have recordings of it. Soviet Venera probes in the 1970s and 80s descended through Venus's atmosphere and captured audio before they melted. And what they recorded is a deep, rumbling roar mixed with crackling static. This is the sound of an atmosphere so thick it crushes spacecraft like soda cans, with winds whipping sulfuric acid clouds at speeds that would strip paint off metal. The atmosphere is 90 times denser than Earth's, which means sound travels differently there, slower and heavier, like you're underwater, but the water is poison and 470 degrees Celsius. To give you a sense of what that pressure feels like, it's the equivalent of being 900 meters below the ocean surface on Earth. The whole planet. That's the baseline, and the Venera landers that captured this sound lasted about 23 minutes on the surface, before the heat and pressure destroyed them. That's roughly the length of a sitcom episode. We sent metal boxes to another planet, and they survived long enough to record hell before they died. Earth's hum. You've been standing on this planet your entire life, and there's a sound it makes that you have never heard. And honestly, that's probably for the best. Earth produces a continuous hum, a low-frequency vibration that seismometers detect constantly, and it's been happening since long before humans existed. The sound is caused by ocean waves colliding with the sea floor and continental shelves, creating pressure waves that travel through the planet's crust and make the entire surface vibrate like a struck bell. The frequency sits between 2 and 7 millihertz, which is far too low for human hearing. We can only detect it with instruments. Scientists didn't even confirm it existed until the early 2000s, which means we lived on a humming planet for all of recorded history and just didn't know. When researchers convert the vibrations into audible frequencies, it sounds like a deep, resonant drone, almost meditative. The kind of sound you'd expect from a Tibetan singing bowl, not a planet. The hum never stops. It's always there, under your feet, whether you're in a city or the middle of the ocean or asleep in your bed. To put it simply, the planet you're standing on right now is vibrating, and it always has been. We've been living on top of a giant musical instrument and didn't realize it until we built machines sensitive enough to listen. That's humanity in a nutshell. Neptune's emissions. The farthest planet in the solar system sounds like it's screaming, and we still don't fully understand why. Voyager 2 flew past Neptune in 1989 and recorded electromagnetic emissions from the planet's magnetosphere. And when NASA converted those emissions into audio, the result was a high-pitched, warbling screech that sounds like something out of a horror movie. The sound is generated by charged particles trapped in Neptune's magnetic field, interacting with solar wind and plasma waves, creating radio emissions that fluctuate wildly in pitch and intensity. What makes it unsettling is that Neptune's magnetic field is tilted 47 degrees off its rotational axis, and doesn't even originate from the planet's core, which means the whole system is chaotic and unstable. The sound reflects that chaos. It's not a steady tone or a rhythmic pulse. It's erratic, unpredictable, almost organic. Scientists still aren't entirely sure what drives some of the specific frequencies Voyager detected. To give you a sense of how far away this is happening, Neptune sits 30 astronomical units from the Sun, which means light from the Sun takes over 4 hours to reach it. Voyager 2 is the only spacecraft that's ever been there. It spent a few hours near this planet, recorded the sound, and kept going. And now we know that out there, at the frozen edge of the solar system, the last planet is screaming into the void. Cool, that's fine. Mars's wind. In February of 2021, NASA's Perseverance rover became the first machine to record direct audio on the surface of Mars. And one of the first things it captured was wind. And it sounds wrong. Not loud, not violent, just off, in a way that's hard to describe until you hear it. The wind on Mars moves through an atmosphere that's less than 1% the density of Earth's, which means sound behaves completely differently there. It travels slower, gets absorbed faster, and arrives muffled and distant even when the source is close. When Perseverance's microphones picked up gusts blowing across Jezero Crater, the audio sounded thin and hollow, like listening to wind through a wall. There's no richness to it, no layered texture the way Earth's wind has. It's just a flat, eerie whistle. And that's with wind speeds that would be considered strong by Martian standards. To put this in perspective, the thin atmosphere means that even a dust storm on Mars, which can engulf the entire planet, would feel like a gentle breeze if you were standing in it. The drama is visual, not physical. The sound matches that. It's quiet, unsettling, and strangely lonely. We sent a $2.5 billion rover to another planet, and one of the first things it did was turn on a microphone and record the wind, just to see what it sounded like. And now we know it sounds like nowhere you've ever been. Jupiter's auroras. If Earth's auroras made sound, they'd probably be beautiful, maybe a soft crackling or a hum. Jupiter's auroras sound like a malfunctioning radio being dragged through a meat grinder, and the reason has everything to do with scale. NASA's Juno spacecraft has been orbiting Jupiter since 2016, and its instruments have recorded radio emissions from the planet's polar auroras, which are caused by charged particles from Jupiter's moons, especially Io, slamming into the planet's magnetic field at absurd speeds. When those emissions are converted to audio, the result is a chaotic mix of hisses, pops, static bursts, and low-frequency rumbles that sound more mechanical than natural. And the energy involved here is staggering. Jupiter's magnetic field is 20,000 times stronger than Earth's, and its auroras are hundreds of times more powerful. The radiation near Jupiter's poles would kill a human in minutes, and fry most spacecraft electronics almost instantly. Juno survives by spending most of its time far from the planet, and only diving close during brief, high-speed passes. During those passes, it records this sound. What's happening is that particles are being accelerated to a significant fraction of the speed of light, and when they hit the upper atmosphere, they release energy in the form of radio waves. We turned those waves into sound, and it turns out the largest planet in the solar system has auroras that sound like a glitch in reality, which honestly tracks. Saturn's rings. Saturn's rings don't make sound in the traditional sense, but they sing anyway, and the song is beautiful and terrifying in equal measure. NASA's Cassini spacecraft detected radio emissions coming from the interaction between Saturn's rings and the planet's magnetosphere, and when converted to audio, the sound is a series of rising and falling whistles, hums, and what can only be described as ethereal choruses. What's creating this is incredibly subtle. The rings are made of billions of ice particles, ranging from dust grains to house-sized chunks, and as they orbit Saturn, they create tiny electrical disturbances in the surrounding plasma. Those disturbances generate radio waves, and Cassini picked them up over 13 years of observation. The result sounds like wind chimes mixed with a theremin, almost musical, but with an underlying randomness that keeps it from ever settling into a recognizable pattern. And the sound changes depending on where the spacecraft is relative to the rings. Different regions produce different tones, different intensities, different harmonics. It's not one sound, it's thousands of overlapping sounds, creating a constantly shifting symphony. To put this in perspective, the rings are over 280,000 kilometers across, but only about 10 meters thick in most places, which means they're essentially a massive, impossibly thin disk of ice that's been orbiting Saturn for hundreds of millions of years. And the whole time, they've been singing. We just couldn't hear them until 2004. By the way, if you're enjoying learning about these topics, I post content like this regularly. I'd appreciate if you subscribed. Thanks. Uranus's silence. When Voyager 2 flew past Uranus in 1986, one of the most surprising things it found was how quiet the planet is. Compared to Jupiter and Saturn, which are electromagnetic chaos factories, Uranus barely makes a sound. The spacecraft detected almost no radio emissions, no plasma wave activity, and very little auroral noise, which baffled scientists because Uranus is still a massive planet with a magnetic field. That field just happens to be weak, oddly tilted, and weirdly offset from the planet's center, which means it doesn't generate the kind of intense electromagnetic environments you see at the other gas giants. What little sound Voyager did detect was faint and inconsistent, like listening to static on a radio station that's barely in range. And scientists still aren't entirely sure why Uranus is so quiet. One theory is that the planet's extreme axial tilt, 98 degrees, which means it essentially rolls around the sun on its side, disrupts the processes that would normally generate stronger magnetic activity. Another theory is that Voyager just happened to pass by during an unusually calm period and missed whatever noise the planet does make. Either way, the recordings we have sound like almost nothing. To put this in perspective, when Voyager's instruments picked up the data, mission scientists actually double-checked to make sure the equipment was working properly. It was. Uranus is just that quiet. You wouldn't survive long enough to appreciate the silence, but at least it wouldn't be loud while you froze to death in methane clouds. Small mercies. Mercury's reconnection. Mercury doesn't have an atmosphere thick enough to carry sound the way Earth or Venus does, but it still makes noise, just not in a way you'd hear if you were standing on the surface. NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015, detected something called magnetic reconnection events, which happen when the planet's weak magnetic field gets slammed by solar wind and essentially snaps and reforms like a rubber band. When that happens, it releases bursts of electromagnetic energy, and Messenger's instruments picked up those bursts as whistling tones and crackling pops. The sound only exists as radio waves, which means it's not sound in the traditional sense, but when researchers convert the data to audio, it sounds like a series of sharp, high-pitched whistles followed by static. And this is happening constantly. Mercury is the closest planet to the sun, which means it's getting blasted by solar wind at intensities that would shred Earth's magnetic field, and its own field is just barely strong enough to deflect some of it. The result is a planet that's essentially whistling at the sun every time it gets hit. We didn't even know this was happening until Messenger got there and started listening. Mercury's been doing this for 4.5 billion years, and we only noticed in the last 15. That's the thing about space. Half of what's happening out there, we just haven't heard yet. Solar oscillations. The sun doesn't make sound in the way most people think of sound, because space is a vacuum and there's no medium for sound waves to travel through. But the sun's surface is constantly vibrating, and those vibrations can be measured and converted into audio. And when scientists did that, the result is deeply unnerving. The sun oscillates because of convection currents inside it. Massive, churning loops of superheated plasma rising and falling, and those movements create pressure waves that ripple across the surface. Solar observatories like SOHO have been tracking those oscillations for decades, and when the data gets converted to frequencies humans can hear, it sounds like a low, rumbling roar mixed with crackling and the occasional sharp burst, like a jet engine running next to a thunderstorm. And the scale here is absurd. The surface temperature of the sun is 5,500 degrees Celsius. The core is 15 million degrees. The amount of energy being released every second is equivalent to billions of nuclear bombs going off simultaneously. And all of that energy creates sound. It's just that there's no air in space to carry it. But if there were, if you could somehow hear the sun from Earth, the sound would be deafening. Scientists estimate it would hit around 120 decibels from 93 million miles away, which is loud enough to cause permanent hearing damage. We orbit a star that is constantly roaring, and the only reason we don't hear it is because space is silent. That's the thing keeping us sane. Titan's descent. In January of 2005, the European Space Agency's Huygens probe descended through the atmosphere of Titan, Saturn's largest moon, and recorded audio the entire way down. And when it splashed into a methane lake, the microphone was still running. What Huygens captured is one of the most alien soundscapes we've ever recorded. The descent sounds like muffled wind, distant rumbles, and the occasional sharp crack, all filtered through an atmosphere that's denser than Earth's, but made mostly of nitrogen and methane. When the probe hit the surface, the audio picked up a wet, sloshing sound, which confirmed what scientists had suspected. Titan has liquid on its surface, but it's not water. It's liquid methane and ethane, pooled in lakes and seas that are hundreds of meters deep in some places. The sound of Huygens landing in that liquid is strange, because methane is denser than air, which means sound travels through it differently. Everything sounds muffled, dampened, like you're hearing it through a thick blanket. And the whole time this is happening, the temperature outside is minus 179 degrees Celsius, cold enough to freeze you solid in under a minute. We dropped a probe into a lake of liquid methane on a moon over 1 billion kilometers away, recorded the splash, and then the probe kept transmitting for another 72 minutes before it finally dies. That's one of the most absurd and incredible things humanity has ever done. We sent something to Titan just to see what it sounded like. And now we know. It sounds like nowhere else. Io's plasma. Io is the most volcanically active body in the solar system, and it sounds like it's screaming. NASA's Galileo spacecraft, which orbited Jupiter from 1995 to 2003, recorded electromagnetic emissions from Io's interaction with Jupiter's magnetosphere. And when those emissions are converted to audio, the result is a chaotic, high-pitched shriek that rises and falls in intensity, like something in pain. What's happening is that Io is being torn apart by tidal forces from Jupiter's immense gravity, which causes the moon's interior to flex and heat up, driving constant volcanic eruptions. Those eruptions spew sulfur dioxide and other gases into space, creating a plasma torus around Jupiter that interacts with the planet's magnetic field in a violent, unpredictable way. The sound reflects that violence. It's not steady, it's not rhythmic, it's a scream. And this has been happening for billions of years. Io has over 400 active volcanoes, with plumes shooting material 300 kilometers into space, and the moon is constantly being resurfaced by lava flows. The electromagnetic emissions from all of that activity create radio waves, and those waves sound like something dying when you play them back as audio. To put this in perspective, Io is a moon that is actively being destroyed, and the sound it makes is the audio equivalent of that destruction. You'd be vaporized by volcanic gases and sulfur long before you could hear it, but the sound is there anyway, constant and unrelenting. And this is the one that makes every other sound in the solar system seem almost peaceful by comparison. Io's been screaming for billions of years. We just couldn't hear it until we got close enough to listen. If this sparked your curiosity about what's out there, consider subscribing so you don't miss future space content. Thanks for watching.